Find the Laplace transform of f equals t squared. Okay, using the definition, we know that Laplace of any function, which is in this case t squared, is equal to this improper integral, the kernel e raised to negative st times the function t squared dt. Then we need to evaluate this definite integral. So we got a product, so we need to use the integration by parts. Okay, and this is infinite, so we need to write down, let's say, from 0 to b, and let b go to infinity, and let me put t squared first and e raised to negative st dt. Now we want to use the integration by parts. U dv equals uv minus v du. For we need to figure out u and dv. So u is t squared and dv is the remaining e to the negative st dt. So du is, now find the derivative of this with respect to t. So 2t dt, integrate with respect to t, so v equals e to the negative st divided by this negative s. Okay, then this is in fact uv minus integral v du, just using this formula. So that is, we still have limit b going to infinity of uv, so t squared times this, so this is negative t squared over s e to the negative st, and 0 to b uv, okay, minus integral v du, this times this. So it's negative s on the bottom, 2, so negative is positive, 2 over s outside, and that leaves t times e to the negative st dt. So we need to work on this integration one more time, and we still have a product, so another integration by parts. In the meantime, we can evaluate this at the upper limit minus lower limit. So this is limit b going to infinity of upper limit t equals b, plug in b, so this is negative b squared over s e to the negative sb. That's the upper limit part, minus lower limit, minus, and there is negative plus e to the 0 is 1. Okay, e to the 0 is 1, so negative, oh, this is 0, t equals 0, so everything is 0, plus 2 over s. Now we need to do another integration by parts. So this is your u, let me write over here. So u is t and dv is the remaining, like earlier, e to the negative st dt. So du is 1, and find the entire derivative e to the negative st divided by negative s. So 2 over s times everything, uv, so that's t times this, negative t over s e to the negative st uv, and we have to go from 0 to b, and we have limit uv minus integral v du. So we multiply, his negative 1 over s can be pulled outside, so plus 1 over s leaves e to the negative st 1 dt, just dt, and this is 0 to b, and b is going to infinity. Okay, so in this case, e to the negative infinity, if b is a positive number, because b is going to positive infinity, if s is also positive, then this goes to 0. Okay, when s is positive, because this will be e to the negative infinity, so there is no contribution from here, so we have only this. So this is limit b going to infinity of, let's evaluate upper limit lower limit here. This is 2 over s outside, upper limit t equals b, so negative b over s e raised to negative sb minus lower limit, plug in t equals 0, so this minus makes plus, but t is 0, so everything is 0. Okay, that upper limit minus lower limit plus 1 over s. Now we can integrate this e to the negative st over negative s, and we are going from 0 to b. Okay, like here this goes to 0 as well when s is positive, because this becomes e to the negative infinity. Then we have now limit b going to infinity, 2 over s outside times 1 over s. Now we need to evaluate upper limit, lower limit, e to the negative sb over negative s, or we could have pulled this outside as well. That's upper limit minus lower limit, plug in t equals 0, so e to the 0 is 1 over negative s. And like in previous two steps, this goes to 0 when s is positive, so this is gone. So we are left with this. When b goes to infinity, this becomes e to the negative infinity, gone. So we don't have b anymore, so I don't have to write this. So 2 over outside 2 over s squared times is a minus and negative plus 1 over s, so that is 2 over s cube, and the condition is s positive. So what we just found here is Laplace of t squared is 2 over s cube, and when s is positive, and you can look at the table and confirm your answer. Final